Hello class, today we will be finding the domain of a function. Now the domain of a function is the set of all possible values that could be used as inputs for that function. The domain is the set of all allowable x values, which are your input values, and the range is the set of all possible y values, which are your output values. In general, we start by assuming that the domain is the set of all real numbers. And then there are three main exceptions. Exception 1, the function contains a fraction having the input variable in the denominator. In this case, the domain is all real numbers for which the denominator is not equal to 0. Okay? The procedure for this is to set the denominator not equal to 0 and to solve for x. So let's look at the first example here. h of x equals 77 divided by 4x plus 9. Okay, we need to set the denominator not equal to 0. So we are setting this 4x plus 9 not equal to 0, and then we're solving for x. If we solve for x, we see that x cannot be equal to negative 9/4. Okay, so the domain is now the set of all real numbers that are not equal to negative 9/4. So it can be anything except that one number. Or if we write it in interval notation, parentheses negative infinity, comma, negative 9/4, close parentheses, union, parentheses negative 9/4, comma, infinity, close parentheses. Now we use the parentheses, not the brackets. The reason we use the parentheses here is because we can never be equal to either of the infinities. So we have to use the parentheses on either of those sides. And we're not equal to negative 9/4, which means anytime it shows up, it has to have a parentheses by it as well. So essentially we have gone through, started at negative infinity, got to negative 9/4, jumped negative 9/4, and then continued on to infinity. So anything in the denominator that has a variable, we set it not equal to 0 and figure out what that variable can't be. Okay. Now, up next, we have exception 2. Exception 2 says that the function contains an even indexed root whose radicand contains the input variable. The radicand must be positive in this case, so the domain is the set of all real numbers for which the radicand is greater than or equal to 0. Okay, so let's look at the procedure for this one. So we want to set the radicand greater than or equal to 0 and solve for x. Now, in our first example, it says g of x equals 56x minus 7 square root 6x minus 11. We need to look at the radicand, okay, which is the square root in this case. All right. If it's even, an even index root, which means 2s, 4s, 6, 8s, 10s. If it doesn't give you a number here, it's assumed to be 2. Otherwise, it'll have a 3, 4, 5, 6, 7, 8. If it's an even number in there, or assumed to be an even number, then we have to worry about it being greater than or equal to 0 because we can't take an even root of a negative number. So we set the interior part right here greater than or equal to 0 to kind of limit what that inside part can be because we don't want it to be negative. And then we solve for x. So we take 6x minus 11, set it greater than or equal to 0, solve for x, and we see that x needs to be greater than or equal to 11 over 6. So the domain is 11/6 to infinity. Okay, it can be equal to in this case because we do have a greater than or equal to sign. So the domain is bracket 11 over 6 to infinity. Okay. Now, next part. So we've had the first two exceptions. Exception 3. The domain is limited by the problem situation. Okay. So the first two are judged basically solely off of the function itself. The third one is based off of the problem situation. So this example says the amount of money lost playing Alfred's self-adapting slot machine is a function of the number of quarters gambled, and Alfred claims that the loss can be approximately modeled by the function f of x equals 300 minus the square root of 90,000 minus 3x dollars, where x represents the number of quarters gambled. We want to find the domain of the function f. Okay. Now, first thing we're going to do is we're going to look at exception 1 and exception 2 within this word problem. Okay. The exception we see here is that we have a radical. Okay. Which means that we need to worry, an even index radical at that, we need to worry about the interior of this radical here being greater than or equal to 0. So we need to set this 90,000 minus 3x greater than or equal to 0. and then we need to solve for x. When we do that, we see that just by the function itself, x has to be less than or equal to 30,000. Okay, this would suggest the domain could be anything from negative infinity all the way up to 30,000. But this is a word problem, so it has some practical limits. Okay, if we look at the word problem, the word problem itself is talking about gambling quarters. Keep in mind, you can't gamble a negative number of quarters. You can't gamble half of a quarter. You can't gamble a quarter of a quarter. So, since one can't gamble a negative number of quarter or a fraction of a quarter in the slot machine, we must adjust this domain. So the domain should instead be all whole numbers between the least amount of quarters you can gamble up to the most amount of quarters you can gamble, which in this case is 30,000. Slight typo here. So our domain is going to live between 0 and 30,000 because it is perfectly fine not to gamble any quarters. Right? That is a possibility that somebody might not gamble any quarters. So the domain is going to go 0, 1, 2, 3. I'm going to show our trend and then show what it goes up to, which is 30,000. Okay. All right. Now, this leads us to the steps that we're going to follow to find the domain of the function. Step number 1, we're going to assume that it's all real numbers from negative infinity to infinity, right? But we might have some exceptions to worry about. So first, after we looked at it and said, okay, we hope it's all real numbers, but we'll look for some exceptions. Second thing we're going to do is throw out or omit anything that causes division by 0 by setting the denominator not equal to 0 and solving for x. Next, we're going to omit or throw out anything that causes the a root of a negative for any positive even integer a. For now, non-real outputs are not allowed. We need to set the radicand greater than or equal to 0 and solve for x. And last but not least, we need to look and see if the domain is limited by the problem situation itself and adjust the domain accordingly. So let's gather through some initial or additional examples here and put them into practice. So A says f of x equals 8x to the 7th power plus 333x to the 4th power minus x minus 5 pi squared. Okay, if I look at this, there's no divisions, there's no radicals, it's not a word problem, so I have no exceptions to worry about, so my domain is simply negative infinity to infinity. Very easy. Let's look at B. F of x equals the 9th root of 3x minus 5. I don't have a division by 0. I have a radicand, but the radical is odd. It's a 9, which is an odd number, so I don't have to worry about it. I also don't have a word problem here, so it's all real numbers. Negative infinity to infinity. That's what our domain could be, is all real numbers. Okay, let's look at C. C says the 8th root of 3x minus 5. We do have an even indexed radical here, so we need to restrict this domain. We need to take the inside of this radical, set it greater than or equal to 0, which we did in step 1 here. Solve for x. We see that x is now greater than or equal to 5/3. So our domain is 5/3 to infinity. We'll use a bracket here on the 5/3 because it can be equal to 5/3. All right, let's look at D. D says f of x equals 4 plus 5x minus 2 divided by the square root of 7 minus 3x. Now this function exhibits two domain restrictions. Exception 1 gives the restriction 7 minus 3x is not equal to 0. Okay, because we cannot have a division by 0. Exception 2 gives the restriction that 7 minus 3x is greater than or equal to 0 because we have an even indexed radical. Okay. Now, if we combine those restrictions and take the most restrictive parts of both, we see that this not equal to is going to cancel out this equal to, so 7 minus 3x has to strictly be greater than 0. Then I just have to solve that equation here for x, and I see that x has to be less than 7/3. So our domain is negative infinity to 7/3. Okay, with parentheses. All right, let's get ready to run through some of these exercises. So take a second if you haven't, get some scratch paper available because you might need it, and let's see if we can run through the domain of this function, or each of these functions, and see what it needs to be. So pause for a second and do that. Alright, so let's look at number 1. Number 1 says f of x equals 3x plus 9 divided by 2x minus 10. Okay. The exception we have to worry about here is what's in the denominator, the 2x minus 10. We know that this means that 2x minus 10 cannot be equal to 0. Then we just have to solve for x. We'll add 10 to both sides. We see that 2x cannot be equal to 10. We divide by 2. We see that x cannot be equal to 5. That's going to be our domain. So what we will do is we will say, okay, that means that we'll start at negative infinity. We'll go up to 5. We'll jump 5 and continue on to infinity. We have to be able to write this in interval notation because most of the time our answer is going to want it in interval notation. Let's look at number 2. Okay, number 2 says g of x equals 3x squared minus 4x plus 1. I don't have any divisions, I don't have any radicals, and it's not a word problem. So my domain is unrestricted. Negative infinity to infinity. Number 3. Number 3 says h of x equals 5 times x minus 1 divided by x plus 2 times 3x minus 8. Now here, we don't want this denominator here to be equal to 0, so we need to set this piece not equal to 0. Now what does that mean? That means that x plus 2 cannot be equal to 0. Neither can 3x minus 8 be equal to 0. Okay, this means that x cannot be equal to negative 2, and this means that x cannot be equal to 8/3. Okay, if it takes you a little bit longer to solve these out and you can't go directly to the answer, that is perfectly fine. Take your time in doing so on the scratch piece of paper that you hopefully went and got. Okay, if I'm writing this in interval notation, I'm going from negative infinity to negative 2, unioned with negative 2 to 8/3, unioned with 8/3 to infinity. And we're good to go. Alright, now I'm going to erase some of this here so that I can have a little bit of clearer space to do the next couple problems. I said by all means pause the video at any time to work it yourself first and then follow up to see what the answer is. The answers are also on the end of this particular worksheet if you ever need to glance down there and practice it on your own. Now 4 says z of x equals 2x divided by x minus 4 times 2x plus 3. Okay. Now the restriction here is in the denominator. It cannot be equal to 0. So x minus 4 cannot be equal to 0. And also 2x plus 3 cannot be equal to 0. Alright. So this means that x cannot be equal to 4. And it also means that x cannot be equal to negative 3/2. Okay. We need to write this in interval notation. Now, just because the 4 is over here on the left doesn't mean we start with it. We start with the smallest number here. So we need to go negative infinity to the smallest number, which is negative 3/2. Union that with negative 3/2 to 4. Union that with 4 to infinity. Basically skipping the negative 3/2 and the 4s. Easy enough. On to the next one. Okay, 5 says k of x equals the square root of 2x minus 16. Well, this is a radical and it's an even radical, so the inside of this radical, this 2x minus 16, needs to be greater than or equal to 0. If I solve for x here, I'll add 16 to the other side, and then I'll divide by 2. Which will show us that x is greater than or equal to 8. Okay, if I write that in interval notation, it's just going to be, it's not a parentheses. Oops, almost made a mistake there. It's not a parentheses. It's a bracket. Oops, not an E, a bracket, 8 to infinity. Okay, because it is equal to, which means we need to exhibit that bracket right there. All right, number 6. Number 6 says j of x equals 3 minus the square root of 2 minus x. We have the square root there, which means that 2 minus x needs to be greater than or equal to 0. I'm going to add x to the other side, which means that 2 is greater than or equal to x, which means x is smaller than 2, which means negative infinity to 2 with a bracket here is our domain. Simple as that. Now, number 7 says p of x equals the cubed root of 5x minus 2. We do have a radical here, but it's an odd indexed radical, which means it's unaffected by negative numbers, which means our domain is negative infinity to positive infinity because we have no exceptions to worry about. Number 8. Number 8, f of x is equal to the 6th root of x minus pi. This is an even indexed root here, so we need to set x minus pi greater than or equal to 0, which means that x has to be greater than or equal to pi, which means that pi to infinity will be my domain. And I will use a bracket on the pi because it's equal to with the inequality. Pi is just a number, 3.14. Hopefully you've seen it before. All right, let's scroll down a bit and look at the next set here. All right. Number 9 says g of x equals 2 minus the square root of 4x plus 20 divided by x times x minus 4 times x plus 1. Now, we have quite a bit going on here. We have the square root, and we also have this division by several factors. Okay, this square root part, we'll start with it. The 4x plus 20 has to be greater than or equal to 0. If we solve through it by subtracting 20, and we get 4x is greater than or equal to negative 20, divide by 4, we will see that x has to be greater than or equal to negative 5. That is one of our limitations here. Now also we need to set this denominator not equal to 0, which means that x cannot be equal to 0, x minus 4 cannot be equal to 0, and x plus 1 cannot be equal to 0. Okay, we already have one completely solved out. If I add 4 to the other side, I'll see that x cannot equal to 4. And if I subtract 1 to the other side, I'll see that x cannot equal negative 1. So we have 4 different style restrictions on this particular problem. Okay, how do we write the inequality for this? Okay, I'm just going to kind of mark 11 out here because we're not working 11. We're just writing the restriction for number 9 here. Okay, so here, what we're going to do, this is why you need scratch paper. We are going to start at our lowest number here, negative 5. X is greater than or equal to negative 5. Okay, so I'm going to do bracket negative 5, and then we're going to continue upwards by our smallest numbers. Our next smallest number is negative 1. So we get to negative 1, we want to jump negative 1. We're going to go to our next number, which is 0. We want to jump it too. And then we're going to go to 4. We've got to jump it as well. And then we can continue on to infinity. So it looks like negative 5, bracket negative 5 to negative 1, parentheses, union, parentheses, negative 1, 0, parentheses, union, parentheses, 0, 4, parentheses, union, 4, parentheses, 4, infinity. Quite a complex setup on that one. Quite a complex setup. Number 10, I've got 2x divided by the square root of 3x minus 18. Now we have two restrictions here. We have the restrictions that 3x minus 18 cannot equal 0, and because it's underneath the radical, and it's an even index radical, it needs to be greater than or equal to 0. Now keep in mind that that not equal to 0 cancels this equal to be 0 out, and we basically get a combined restriction here that 3x minus 18 has to be strictly greater than 0. If we solve for x here by adding 18 to the other side and then dividing by 3, we see that x has to be greater than 6. Okay, which means in interval notation we're going to go 6 to infinity. Alright, we've gotten all the way up past number 10. Now I'm obviously going to have to do some erasing so we can go further. So if you hadn't gotten all this yet, obviously take a minute, pause. I'm going to erase some of this work here, clean my paper up a bit so that we can do number 11 and 12 next without having anything in the way. I obviously encourage you to do this on scratch paper. Okay. Number 11 says f of x equals 9x to the 33rd power plus 4x to the 5th power minus 222x minus 523 plus pi. I don't have any divisions, I don't have any radicals, and it's not a word problem. So my domain is negative infinity to infinity. Number 12. h of x equals 3x to the 7th power plus 8x squared minus 9 divided by 11x minus 25. I just have to make sure that 11x minus 25 is not equal to 0 for my domain. Okay, so that means I'm going to add 25 to the other side. This is going to give me 11x cannot be equal to 25. I'm going to divide by 11. So x cannot be equal to 25 divided by 11, or 25 over 11, which means that I'm going to start at negative infinity. I'm going to go to 25 over 11. I'm going to union that with 25 over 11 to infinity. Essentially just jumping that 25 over 11. Easy enough. Number 13, g of x equals 56x to the 444th power minus 7x to the 3rd power times the square root of 73 minus 2x. Okay, just have to worry about that radical being greater than or equal to 0. So if that's the case, I will take, it'll look like 73 minus 2x is greater than or equal to 0. I will subtract 73 from both sides. Okay, so I have negative 2x is greater than or equal to negative 73. I'll divide by negative 2. That'll make the negatives go away, but it'll also flip the inequality sign so that x is less than or equal to 73 halves. Okay, that means negative infinity to 73 halves. Bracket is our domain for number 13. Keep in mind your properties of inequalities, especially when it comes to multiplication and division by negatives. It causes that sign to flip. Alright, I'm going to do some erasing here too, so pause if you need to. Stop anytime you need to. I'm just giving myself some space for number 14. Okay, just giving myself some space for number 14. I'm going to do the same thing for number 15 that's coming up too. Alright. Let's see. Number 14 is 78x plus 66x minus 2 pi divided by the square root of 31 minus 44x. We have two restrictions here. Okay, 31 minus 44x cannot be equal to 0 because it's in the denominator. And because it's underneath a radical as well, it has to be greater than or equal to 0, which means if we combine these restrictions, I got to get rid of that equal to part here, which means that 31 minus 44x has to be strictly greater than 0 in this particular domain. If I solve for x here, I could subtract 31 from both sides. I'm going to get negative 44x is greater than negative 31 divided by negative 44. Negatives go away, but the sign switches. I'm looking at 31 over 44 is greater than x, or x is less than 31 over 44, which means that negative infinity to 31 over 44 is our domain. We use parentheses because there's no equal to there. Let's go on to the next one. Number 15. 15 says g of x equals the 5th root of 34 minus 5x plus the 4th root of 5x minus 7x. 5 minus 7x. Alright. We don't have to worry about the 5th root because it's odd, but we do have to worry about the 4th root because it's even. So we need to look at 5 minus 7x being greater than or equal to 0. We can solve that out pretty easily here. Subtract 5 from both sides. I'm looking at negative 7x is greater than or equal to negative 5. I'm going to divide by negative 7 here on both sides. The sign's going to switch, so x is less than or equal to 5/7. What that means is we're going from negative infinity to 5/7, but we're using a bracket because the equal to is retained. Alright, once again, doing a little bit of erasing here so I can continue on to the next problem. Still need to do number 16. Don't want anything in the way of it. Okay, so make sure you have that written down. Pause if needed. Rewind if needed. Alright, let's work number 16. Alright, number 16 says f of x equals 8 pi x plus the square root of x minus 3 divided by x minus 5. Okay, the denominator tells us that it can't be equal to 0. The inequality means that it needs to be greater than or equal to 0. Let's combine these two restrictions. Okay, the bottom restriction lets me know that x cannot be equal to 5. The top restriction here lets me know that x has to be greater than or equal to 3. Okay, which means I'm going to start at 3. So bracket 3. I'm going to go up to 5, parentheses, union that with 5 to infinity. And I'm done. Got to be able to do these domain problems, especially the straightforward, just function ones. But they're going to get a little more complicated, perhaps, because we're going to get some word problems. Let's look at number 17, the word problem. It says, while visiting his grandparents for the first time in 15 years, Bob goes to collect some honey from his favorite honey tree and instead collects a significant number of stings from the hive's new killer inhabitants. In his delirium, Bob blunderingly postulates that the level of pain in BPUs, that's Bob pain units, is a function of the number of bees that stung him, and the function is modeled by f of x equals 20 minus the square root of 400 minus 25x. Find the domain of f. Okay, the domain here, the only thing we need to worry about with the actual function itself is this needs to be greater than or equal to 0. Okay, so if I have 400 minus 25x is greater than or equal to 0, I can solve for x by adding 25x to both sides, getting it by itself. So this is going to be 400 is greater than or equal to 25x divided by 25. And this is going to show me that, let's see, 400 divided by 25 is what? 400 divided by 25 is 16. Okay, so I have 16 is greater than or equal to x. Now, by just the function, it says that 16 is greater than or equal to x, but we got to think about this practically. Okay, x is the number of times that the number of bees that stung Bob. Okay, think about practically how many bees could sting Bob. Negative bees can't sting Bob, so we have to get rid of all the negative numbers. You can't get stung by half of a bee or a quarter of a bee, so we just have to work in whole numbers. So the number of possible bees that stung Bob are going to be anywhere from 0, 1, 2, 3, ... all the way up to 16. So this is our domain D. Our domain is 0 to 16, but just the whole numbers. Okay, it can't be negative numbers because you can't have a number of negative bees sting you. And it can't be halves or quarters or pieces of numbers because that is neither possible. All right. Number 18. Number 18 says, after her final exam, Cecilia climbs to the top of the water tower and throws her textbook with an initial upward velocity of 34.3 meters per second. The book flies through the air in a graceful parabolic arc, and after exactly 10 seconds of flight, it lands thud in the tar pit 147 meters below its release point. The function h of t equals 147 minus 4.9 t squared plus 34.3 t gives the height of the book in meters above the tar pit, where t is the second since the book was released. We want to find the domain of h of t. Hint, the function does not apply after the book hits the tar pit. Alright, so we have this function here. Nothing with the function itself, the h of t function itself, do we have to worry about for the domain, because we don't have any divisions, we don't have any square roots, or any radicals to worry about. The only thing we have to worry about is the problem situation itself. T represents time. Okay, the time of the flight of the book, right? So, time of flight of the book starts whenever it releases my hand. Time cannot be negative but it can be 0. 0 is when it's in my hand, right? So time's going to exist somewhere between 0 and whenever it hits the bottom of the tar pit, which they tell us in the problem is exactly 10 seconds later. So our domain is 0 to 10, because the function does not apply after those 10 seconds, and it can be any time between 0 and 10, because time is continuous. Alright, number 19, if you have agreed to pay off a loan of $1,600 with $128 interest by making monthly payments of $144, the amount of money remaining to be paid on the loan can be modeled by the function b of x equals 1,728 minus 144x dollars, where x is the number of payments that have been made. We want to find the domain of b of x. Alright, we're paying off of a loan. The function itself is a very simple function. We don't have to worry about divisions or square roots or even indexed radicals. So it's limited solely by the problem situation itself. Paying off a loan. Number of payments is what we're looking at. Can't make a negative number of payments. So the least amount of payments that we can make are 0. Okay? Now, think about this. How many payments need to be made? Okay? Because I don't want to pay over the amount of payments I need to pay, because I'm not trying to give them free money. Once it's paid off, I'm done paying it. I shouldn't have to pay you any more payments. Okay, so let's figure out when this function will come to 0 and I won't owe you any more money. Okay, if we solve this for x, I get 144x equals 1,728. 1,728 divided by 144 is going to give us 12. So x equals 12. Once I've made 12 payments, I will have paid off the loan and I will owe $0. Alright, now can we make a half a payment or a quarter of a payment? We're going to say no. We're only paying it in full each time that payment is owed. So my loan exists here from 0 to 12 payments. Nothing in between. Once I get to 12 payments, I'm done paying it. I don't have to pay it any longer. Number 20. The daily cost C in dollars of removing pollution from a smokestack in an electrical plant is related to the percent of pollution P being removed according to the equation. C of P equals 10,500 divided by 100 minus P. What is the domain of the function C of P? If we look at the function itself here, the bottom part can't be equal to 0. The denominator here can't be equal to 0. So if I solve that, I see that, hey, P cannot be equal to 100. Okay, so I guess it's impossible to reduce 100% of your pollution here. Alright, so let's think practically now. What's the least amount of pollution that can be removed? Because we've already looked at our restriction with the actual function itself, but according to the word problem, if we think about it, what's the least amount of pollution that can be removed? I would say 0, right? You could remove 0 pollution. And I would say it would be okay for that to be equal, right? So we might want to actually put a bracket on it. You could remove absolutely no pollution. And you could remove any percent of pollution between 0 and 100. But our equation says we can't exactly make it equal to 100, so we need to put the parentheses on 100. So our domain looks like any percent between 0 and 100, just not necessarily equal to 100%. Possible to remove all pollution. Number 21, the market demand in thousands of units for digital cameras is given by the function D of P equals negative 0.2P plus 130, where P is the price of camera. Okay, find the domain of D of P. Alright, now here's what we want to do here. Okay, the least amount that you could charge for a camera would technically be like $0, right? And that's why I scroll down to see what we have for the actual answer here. You're not going to find a camera for $0, but anything over $0 actually means it's for sale and not being given away. Okay, so it's going to start at 0 here. The problem situation here is the only thing limiting this. The actual equation itself doesn't limit anything. But camera's not for sale if it has no demand either. So technically, if D of P is equal to 0, right? Technically, if D of P is equal to 0, I have no demand, and if it's not demanded, it's not really sold because it's not gonna sell. So if I solve for P here, subtract 130 to the other side, I get negative 130 equals negative 0.2p. If I divide by negative 0.02p, I'm going to see that P is going to be 650. Okay, 650 is where we have no demand, and I believe we're going to put a bracket on the 650 because it shouldn't pass that point, but I guess it is possible to be that point. So our domain here is 0 to 650 for the price of the camera. Okay. Number 22, the Factor's new training program for production teams allows each team up to but no more than 25 hours of training. The average time in hours that a new production team takes to assemble 1 unit of product is given by H of T equals 5 plus 3T divided by 2T plus 1, where T is the number of hours spent training the team. What is the domain of the function of H of T? T is the number of hours spent training the team. Alright, we know that. Okay, no more than 25 hours is already stated here. Okay, we don't have to worry about going over that number. We do have to worry about this division by 0 here that's possible. So we need to set 2t plus 1 not equal to 0 and solve it. So I'm going to subtract 1 here. Okay, and then I'm going to divide by 2. So I'm going to see that 2t is not equal to negative 1. I'm going to divide by 2. So t cannot be equal to negative 1/2. T is time. T is the number of hours. Can you have a negative ½ hour? No, you can't. So I don't even have to worry about this restriction here. Alright, so the amount of training that we could be between in a practical sense, when they tell us we can't train more than 25 hours, but the amount of training that we could have, it is possible that they not train you at all. 0. And they could train you for up to 25 hours. So our domain here lives between 0 and 25. Could be exactly 0, could be exactly 25, or anything in between. Alright, number 23, the intensity of light is inversely proportional to the square of the distance from the source. It's given by the function I of D equals 0.65 divided by D squared, where I is the intensity in foot candles and D is the distance in feet from the source. Let's find the domain of this function. Straight off the bat here, we see that this denominator cannot be equal to 0. D squared not equal to 0. Same thing as D is not equal to 0, because if you took the square root of both sides, square root of 0 is 0, so we know that D can't be 0, which obviously makes sense because if you have a candle or you have a flashlight and you're shining it upon a source or an object, you can't exactly make them one of their own, meaning that if I'm shining the flashlight, say, at the wall, I can't put the flashlight literally physically inside the wall. I can get it really, really close to the wall, but I can't literally force the two objects together up to like a certain atomic point, which technically makes sense, right? Now, going the other direction, so it can't be 0, but going the other way, I could back that light source out as far away from that wall as I want it to be, or whatever I'm shining it on. So technically, I could go back as far as infinity. Now let's think about negative infinity. Can you have a negative distance here? Okay, not really. Okay, because just because you change direction here doesn't mean you really have a negative distance. So the domain of this function is going to be somewhere between 0 and infinity, because I can't exactly be exactly on the object, but I can back as far away from the object as I want to. I can be an infinite distance away from this object if I want to just keep going and going and going. Okay, so hopefully the domain makes a little bit more sense to you now. Hopefully, going through some of those, you see where we got some of these answers. You can always check yourself right here on the solution set. I encourage you to print this out and practice it on your own. Hopefully you did that before you watched the lecture maybe. But if you didn't, print you out an extra copy, especially before the test. Go through it, practice it, see if you can do it on your own. and come up with the domain on your own, because a lot of these questions will be recycled when it comes to tests and quizzes. If you have any questions, email me, let me know. Other than that, I will see y'all next time.